Hello friends, you are welcome to my YouTube channel JK Academy India. Today in this video, we will talk about the auto transformer. A transformer in which a part of the winding is common for both primary and secondary circuit is called an auto transformer. In a two-winding transformer, primary and secondary windings are electrically isolated, but in an auto transformer, both are not identically isolated. Rather, a section of same winding acts as secondary or primary of the transformer. Construction. The core of an auto transformer may be rectangular or circular ring type. It may be a rectangular in shape or it may be a circular as seen here. This is the circular. A single winding is wound around one or two limb of a rectangular core as shown in the figure, and it is wound over the ring. Terminal B is taken as the common point from which one terminal of primary and one terminal of secondary is taken out. Here in this, B point is common for primary as well as secondary winding. Here primary winding is excited with voltage V1 and load is connected across the secondary winding V2. So the number of turns for the primary winding is fixed, that is N1, but for secondary winding number of turns are also same, but at which position we are taking out the current from this pointer, that will be the number of turns for the secondary winding. So secondary winding number of turns may vary from 1 to N1. N1 is the number of turns of primary winding. The second terminal of the secondary winding is connected to point C, which may be fixed or movable. Okay, as shown in the figure, we will see next the number of turns between AB are taken as N1, as I have earlier told you. The number of turns for BC are now taken as N2. Thus, one section of the winding acts as primary and other acts as secondary. When the number of turns of secondary N2 is less than the primary, the auto transformer works as a step down transformer, whereas if the N2 are more compared to N1, it works as a step up transformer. So in this figure, these are the rectangular cores, and winding is placed on one of the core. You can say that is the complete primary winding, and secondary winding is from this to this. This will be the secondary winding. C point is the common point. A B point is the common point, sorry, and C is the variable point. B is a common point for the primary as well as secondary, and C is a variable point or it may be a fixed point also as per the requirement. Now here we can see that N1 are the number of turns in primary and N2 are the number of turns in secondary. Here we have connected one terminal of the secondary side. So N2 are less than N1, or you can say N1 are greater than N2. So in that case, this is called step down transformer. Here in the second figure, we can see that the number of turns for primary are N1, whereas the number of turns for secondary are N2, and in this case N1 are less than N2. So this is called step up transformer. And here the third figure shows that the number of turns for the primary windings, suppose N1, but number of turns for secondary winding may be less than N1, and it may be taken as a tapings from 1, 2, 3, 4, 5 and 6. So up to fifth terminal N1 will be equals to N2. At that case the voltage will be same in primary and secondary, V1 equals to V2. And here if the terminal C is on 3, 4, 3, 2 or 1 terminal, then V2 will be less than V1. And if C point is connected to this taping 6, then V2 will be greater than V1. Okay, so thus auto transformer works like step down or step up transformer. Here this is the circular core and this is the pointer for the secondary winding. Here the N2 turns of the secondary winding are less than N1. Here in this case N1 are less than N2, means N2 may be more or less, but here pointer is placed N2 greater than N1, so this is called step up transformer. These are the transformers available in the market. Some people says variac also. Now the pictorial working. When AC voltage V1 is applied to winding AB, an exciting current starts flowing through the full winding AB. If the internal impedance drop is neglected, then the voltage per turn in winding AB is V1 upon N1, and therefore the voltage across BC is V1 upon N1 into N2. When switch S is closed, I2 starts flowing through the load and current I1 is drawn from the source. Neglecting losses, input power equals to output power. So V1 I1 cos phi 1 will be equals to V2 I2 cos phi 2. Here current I1 is flowing through the primary winding and I2 is flowing through secondary winding. So in this portion the current flowing in the winding will be I2 minus I1. If internal leakage impedance drop and losses are neglected, then cos phi 1 equals to cos phi 2, hence V1 equals to V2 So V2 by V1 equals to I2 by I1 is nothing but N2 by N1 transformation ratio. Let at any instant the exciting current flows from AB and establishes a working MMF directed vertically upward in the core. When the switch S is closed, the current in winding BC must flow from B to C. In order to create an MMF opposing the exciting or working MMF as per the Lenge's law, since the working MMF in a transformer remains constant at its no load value, the primary must draw additional current I1 from the source in order to neutralize the effect of current IBC. In winding AB, I1 flows from A to B, while in winding BC, I2 flows from B to C. Therefore, the current in the winding BC is I1 from C to B and I2 from B to C. Hence, the current I2 is greater than I1 because V2 is less than I1 and their MMF are opposing each other at every instant. Current IBC is equal to I2 minus I1 as I have told you earlier in previous slide. Now the MMF of the winding AC equals to I1 N1 minus N2 is equal to this, and it will be IBC into N2 MMF of the winding CB. It is therefore seen that the transformer action takes place between winding section AC and winding section BC. In other words, the volt ampere section across winding AC are transferred by transformer action to the load connected across winding BC. Power transferred in VA will be equals to V1 minus V2 into I1, and total power transferred to input power equals to V1 I1. Transferred power divided by input power equals to 1 minus V2 by V1. So power transfer equals to 1 minus K power transfer. This. Out of the input volt ampere, V1 I1, only VAC and IAC means V1 minus I2 I1 is transferred to the output by transformer action. The remaining power in volt ampere required for the output are connected directly to the secondary from primary due to electrical connection. So the power conducted in VA equals to total power input in VA minus transferred power in VA. So it will become V1 I1 minus V1 minus V2 into I1. So it will be V2 upon I1. So power conducted in VA, power divided by power input in VA is nothing but the transformation ratio. Power conducted equals to K into power input. Hence, transferred power upon input power is equal to 1 minus K and conducted power upon input power equals to K. So, transferred power divided by input power will become V1 minus V2 upon V1, or high voltage minus low voltage divided by high voltage. Phasor diagram of an auto transformer. V1 is the applied voltage, I1 is the supplied current, I2 is the load current which also flows through BC, I2 minus I1 is the resultant current in section BC. Phi is the flux produced in the core linking with winding. This is I2 minus I1 and this is I2. An EMF is induced in both sections of the winding ECA and EBC, which act in opposite direction to the applied voltage to balance it. This is ECA and this is EBC. The phasor diagram of an auto transformer as shown, where V2 is the voltage, V1 is the voltage applied across the load, V2 is the voltage applied across the load represented by phasor OA. Here in this circuit, this is V2 represented by OA. Let the load is inductive, then current drawn by the load I2 lags behind the voltage V2 by an angle of phi 2. This is the angle phi 2 and this is the current I2 flowing in BC circuit. Current in BC will be I2 minus I1. So it will become I2 bracket 1 minus K is the transformation ratio. This current IBC is represented by phasor diagram OC. This is IBC. There is a voltage drop in the resistance and reactance of the winding. To represent the drop, a line parallel to OC from A, take AD, line OC from A and take AD, that is I2 1 minus K R2, draw perpendicular from D on OC. This is AD and this is DE, ADE. In the triangle ADE represent the voltage drop in the impedance of the winding BC. Here OE represent EMF induced in the winding BC. This called EBC. The induced EMF in section CA, ECA, this one, equals to EBC 1 minus K upon K in phase with EBC by vector OF. This one. Draw this vector to the other side of OG, OF, hence OG is equal to minus EGA. Draw the vector OH, I1 minus KI2 minus KI2. This is vector OH. It is just opposite to I2. Draw impedance drop triangle GJK. This is the impedance drop triangle for the section CA, where JG equal to I1R1 parallel to I1 and JK is I1X1 parallel to I1. Here phasor OK is equal to VAC. This is the VAC. Phasor sum of EMF OG and impedance drop GK. Finally, V1 is the phasor sum of VAC and VCB. So V1 is the phasor sum of VAC and VCB. So V1 equal to VAC plus VCB is equals to VAC minus V2. This is VAC and this is V2. Equivalent circuit of an autotransformer. While drawing equivalent circuit of an autotransformer, it may be considered as a two-winding transformer where one section AC of its winding can be taken as its primary having voltage VAC and the current I1. The other section CB can be taken as the secondary having output voltage V2 and current I2 minus I1. So this is the equivalent circuit for the autotransformer. It is just similar to our previous circuit of single phase transformer, but here the mutual inductance and resistance both are taken at left side, and this is the primary winding resistance and inductance, and this is the secondary winding. So here the current ratio will be I1 upon I2 minus I1. So finally the current ratio will be K upon 1 minus K. And the ratio of EMF will also be K upon 1 minus K. So we can say that auto transformer with turns ratio K is equivalent in its transformation to the ordinary transformer with the ratio of K upon 1 minus K. So this is an auto transformer circuit, and if we want to draw an equivalent circuit for the auto transformer, it will look like this. The number of turns will be N1 minus N2, and here the number of turns are N2. Current in this circuit is I1, and in this I2 minus I1. Let the primary impedance is R1 JX1, secondary R2 plus JX2, primary current is I1. So REP will be R1 plus R2 1 minus K upon K square. In single phase circuit we have seen R1 plus R2 K square, single phase transformer, but in case of auto transformer this K will become 1 minus K upon K. So reactance equivalent will also become X1 plus X2 to this. V2 dash equals to V2 into again that same factor, and VAC equals to this, and the applied voltage V1 will be V1 will be V2 upon K plus I1 R equivalent plus J equivalent. Here is the simplified circuit for an auto transformer is drawn. So this is the applied voltage, this is the R equivalent, X equivalent, this is the I1 current and the voltage V2 upon K. The equivalent circuit of an auto transformer where exciting current is not considered. If exciting resistance and reactance is considered, then equivalent circuit will look like this. If input voltage is applied across BC and the load is connected across AB, then the transformer acts as step-up transformer. As we have discussed this matter earlier in the principle of auto transformer. Now we will see the applications of auto transformer. Single phase and three phase auto transformers are employed for obtaining variable output voltage at the output when used as variac auto transformer. These are known by their trade name such as variac, demostat and autostat. This is called the torsial core and winding. One carbon brush is attached with this lever to make the contact with the winding. A variable ratio auto transformer or variac has a toroidal core and toroidal winding. A sliding contact with the winding is made by carbon brush as shown. The position of the sliding contact can be varied by hand wheel which changes output voltage. These are mostly used in laboratories for testing purpose. Auto transformer are also used as boosters for raising the voltage in AC feeders. A furnace transformer for getting a convenient supply to suit the furnace winding from normal to 30 volt AC supply. Auto transformers with a number of tapings are used for starting induction motors and synchronous motors. When auto transformers are used for this purpose, they are known as auto starters. So, thanks for watching. Take care and goodbye.